Hi, Math 3. Hope you guys are staying warm. I wanted to just do a little model of a screencast of sort of the two types of questions you might be asked on our quiz, which will not be this week. I still haven't decided exactly when that's going to be, but it'll either be sort of next Monday or Tuesday, so the 27th or the 28th, I think, because we only meet once this week. So sad. All right, so we're going to try to find our six things. Right, both kinds of intercepts, domain, range, vertex, and axis of symmetry for these two parabolas here. And we see, first of all, they're in two different forms, right? We have our purple friend on the left. This is vertex form, because we can find its vertex really easily. And then over here we have standard form in green, okay? So I'm gonna sort of go through what we can find really quickly with each. Okay, and obviously our first bet is to say that, we have the domain as negative infinity to positive infinity. That's sort of the easy thing to say. So that's sort of our first guy here. And then our second guy, also very easy in vertex form, right? Is just read the vertex out. Remember, we have to switch those coordinates for x, so it's -1, it's not +1, and then +16 for the y coordinate. Okay? What else do we know about this parabola? I'm going to say, because of this negative sign right there, it opens down. So that's sort of another conclusion we have. Okay, and with the vertex, we can actually find something pretty easily, right? Well, we know the vertex, divides this is on that axis of symmetry, right? The line that divides my parabola in half, right? So we can find my axis of symmetry, and we know that that sort of has to do with this x coordinate of the vertex, right? So that's going to be x equals -1. That vertical line, right? So that's my third thing that I know. Also, we said this opens down, right? It opens down, so I can also find my range once I have my vertex, right? My range, since it opens down, this point right here is going to be a maximum. All right, so this thing opens down. That's its biggest value. So we know it's going to go from -infinity with with a parenthesis up to 16 with a bracket, okay? And then now we sort of have two tricky things, okay? These are the things that are tricky in this form. Let's find the y-intercept first. So to find the y-intercept, we're going to have to set x equal to 0, right? So we'll then solve for y. So we're going to get something that looks like this, right? And then that's just -4 times 1 squared, which is just 1, plus 16, or this is going to be +12. So my y-intercept is 0, 12. And then last but not least, we need to find some x-intercepts, right? Sort of the hardest thing to find here. I don't know, maybe. And then we're going to want to plug in 0 for y and solve, right? 0 in for y, because we're trying to find these x-intercepts. Okay, and so when we're faced with this, right, we want to get everything away from x. So the easiest thing is to subtract 16. And the next easiest thing is to divide by -4. And then we'll get 4 equals x plus 1 squared. And again, we've said this a million times. That means something squared has got to be, if something squared is 4, then that something is either +2 or -2, right? So we get x plus 1, right? Because we take our square roots. We get x plus 1 equals +2, or x plus 1 equals -2. That leaves me with my two answers, x equals 1 and x equals -3. So my two x-intercepts are -3, 0, and 1, 0. Really fast. If we had to quickly graph this, right, we could graph, all the points that we just found. Maybe, we're going to have a big scale here. So maybe -116 is up here, right? -1, 16. 0, 12 might be somewhere like this. 1, 0, and 0, -3, right? Remember, because of that -4 out front, this number right here, this thing gets big pretty fast, right? So this thing's going to look something like this. There we go. Okay, so that's what that sketch would look like. So that's one sort of exercise if this is in vertex form. Now let's think about what happens if it's in standard form. And let's think about what we know really easily off the bat with standard form. So easiest thing to find again is going to be my domain. And I'm actually going to say my second easiest thing is a little bit different than what we did in class. I'm actually going to say it's my y-intercept. Okay, and my y-intercept, I plug in 0 for x, right? And if I plug in 0 for x, I can sort of just ignore these two terms because they're going to both be 0, right? We can ignore those two highlighted terms. And so if I plug in 0 for x, I'm going to get something like this, which is just y equals 4. So we got 0, 4 pretty easily. But I don't know anything else about this guy, really, until I factor it. Okay, it's going to sort of unlock my other things. Okay, so we're going to try to factor this thing. And what do we notice about this? This 21 is ugly. And furthermore, it's really ugly because 21x squared and 4 don't actually share much in common. So we're going to use what we talked about in class the other day. So to factor this, we said this is ax squared plus bx plus c. And we said, okay, we're going to use the AC method. And so the AC method said we multiply to BAC, add to BB. So AC in this case is 4 times 21, or 84. And B is negative 20. So we're looking for numbers that multiply to be 84, and add to be negative 20. And you guys can pause this and try to figure that out if you want. Okay, so when we thought about the things that go into 84, you might have said 21 and 4, but those don't quite add up to negative 20. It turns out 14 and 6 do. So negative 14 and negative 6 are the two numbers we're looking for. So what did we do? We, in our factoring process, sorry, I shouldn't even have that. In our factoring process here, we said, okay, this y equals 21x squared. We really said, hey, that 20x could be minus 14x minus 6x plus 4. Okay, and then we sort of grouped this into two different sets of 2. All right, we grouped it into two different sets of 2. And we said, okay, what do I have here in common? Well, we have y equals, and then in this first set, we have a 7x in common. So I can make this 3x minus 2. And then in my second set, I'm going to pull out a negative 2. Because 6 and 4 have a 2 in common. One of them is negative, so we're going to pull out this negative 2. And what am I going to be left with here? Also 3x minus 2. Then you're asking yourself, how many 3x minus 2s do I have? Well, I started with 7x of them, and then I took away 2. So we'd be left with 7x minus 2 of my 3x minus 2s. Okay, so why did we factor? We factored to find my x-intercepts. And if I wanted to set y equal to 0 and solve this, well, we have that thing called the zero product property, right? Where I have 0 equals a times b. Therefore, a is 0 or b is 0. So if a is 0, 7x minus 2 must be 0, or b is 0, 3x minus 2 equals 0. And I think you'll see that we're going to get 2/7 or 2/3. Okay. Well, these numbers aren't great in terms of messiness here, but we're gonna work our way through it. Okay, so we have 2/3. Sorry, I didn't mean that. My x-intercepts are 2/3, 0, and 2/7, 0. That's kind of messy. Okay, so can we find the axis of symmetry from that? I don't know. Let's try. Well, we know that the axis of symmetry has to be the average of these two things. So I know you guys love your fractions. So we want to find the average of 2/3 and 2/7. Well, we need to put them over a common denominator, right? 2/3 plus 2/7 over 2. That's really what we're trying to find here. So let's add those things. So 2/3 plus 2/7. Let's use 21, right? So that's 14 over 21 plus 6 over 21 all over 2, which is 10 over 21 over 2, which is, of course, is 5 over 21. It's a beautiful term there. Hang on, did I make a math mistake? I think I made a math mistake. Oh, I already divided. This is 20 over 20 over 21, my bad. So this would be 10 over 21. I divided twice. Bad, Mr. Perlis. Okay, 10 over 21. At least we noticed that our numbers didn't make sense. So this axis of symmetry is actually x equals 10 over 21. It's kind of a weird number, and we don't really know what that is. It's about a half, right? Okay. And then that will also tell me how to find my vertex. And how would you find your vertex? Well, we'd plug this into my equation, okay? So we'd plug this in. I'm going to use the factored form, but you could use the original, and that would be fine. So here's my factored form. Your quiz, by the way, won't have numbers that are this gross. I just wanted to, give you some things that were a little bit annoying here. And I'm going to plug in 10 over 21 in for x and solve for y, all right? Because that's what y would be when x is 10 over 21, which, of course, is the coordinate of the vertex. So this thing is really 70 over, well, we can actually simplify that. What am I doing? This 7 over 21, right, becomes a 3. So I have 10/3 minus 2. And then this becomes 10/7 minus 2, right, because this 3 and this 21 become a 7 down here. I want to clean up my friends here. I want to put some common denominators in. So we're going to have 10/3 minus 6/3, because that's what 2 is, times 10/7 minus 14/7, because that's what 2 is. And then I'll be left with 4/3 times negative 4/7, or negative 16 over 21. So I love all this algebra we're having to do. My vertex is 10 over 21, comma, negative 16 over 21. That's good. Okay? And then lastly, we knew this parabola opened up because of that positive 21 in front. So my range has just got to be going up from this y coordinate, right? It's a 2 right there. All right. I know these numbers were messy. I thought this was I hope you thought this was helpful. I'm going to ask that you guys do all of that sheet that I posted for homework as sort of your asynchronous work for Thursday. Thursday, we will probably practice more. We might gamify it. I haven't decided yet. Sort of depends on what we're feeling. And, that is going to be a 6th period. So our only meeting this week is a 6th period, which I know you guys love. So we'll have a good period of math on Thursday afternoon. And then we might take our quiz in a non-assessment period. I haven't decided. All right. But that wouldn't be until next week. All right. Stay warm, friends.